Welcome to Sravz Technical Series. This is session 2 of the Fundamentals Controller sessions we are going through. So this is the Fundamentals Controller session. In this session, we are discussing the creation of the pre-signed URLs, and then we used Redis to save the pre-signed URLs. So in session 1, we went through these topics. At the end of the session 1, I mentioned that we are going to use a 3-tier cache where the fundamentals controller will first get the data from Redis. If it is not present, it will query S3 and generate the pre-signed URL. And if the data is not there in S3, we use a data provider to query the data from the provider, get it from the provider as a REST API call, save the data to S3, and once we save the data to S3 in a prefix, we then generate the pre-signed URL, save the pre-signed URL to Redis, and then send the pre-signed URL to the client. In today's session, we'll discuss the data provider implementation. I'll go to the session 2. So to implement data provider, I had to use these various components in Boost ASIO, ASIO, Boost Spawn. Then I had to use std future and promise. And then after using these two, I think there's a possible deadlock, so we'll discuss that. And then also we use the REST client implementation in Boost ASIO to perform get call on the data provider endpoint to get the data. So before we go through the code base, I'll do a quick demo. So the server is running now. I started the server and the web server is running, and I added a new URL, fundamentals, which will give you the pre-signed URL, fundamentals, and we pass Sravz ID with the ID. So now I'll run it once. So it returns the pre-signed URL. Right now the pre-signed URL is already in the Redis server, so it's returning from the Redis, but at least the implementation works from end to end. In the unit test cases, I'll test the individual test pieces, so that will give you a good idea of the whole implementation. So now I'll switch back to the unit tests. All the tests have passed. So I have a data provider test, which is based on callbacks and promise, and then the fundamentals controller tests, which will run and get the pre-signed URL. So first today in this session, we'll just focus on the data provider. We will skip how the data provider is integrated into fundamentals controller. It's just a shared pointer, so we can skip that piece. So we'll just focus on data provider today. Before we go through the code, I'll just run these two test cases. I'll trigger this one also. So both the test cases are running. 100% passed, 100% passed, and both the test cases have passed. So now we'll go to the code base for the data provider. The code base is already in the gist here. I'll show the same in the Visual Studio Code. I'll close out the terminal and then also squish this. So the implementation is the fundamentals controller. It's a typo, it's a fundamentals controller. Fundamental controller will call the data provider and pass the Sravz ID. The data provider will use Boost Spawn so that the data provider runs always on a in a strand, and then the fundamentals controller using futures and promise will wait for the output from the data provider. Once the data is obtained by the data provider, then the fundamentals controller will save the data to S3, then generate the pre-signed URL and send it to the client. So I'll open the data provider. The data provider, going forward, our goal is to implement an abstract class with pure virtual functions equal to zeros. So we'll use this as an interface, and then we'll implement that interface in our actual concrete class like this. So this way, in a later session, we'll use the interfaces for dependency injection using Boost dependency injection. So for today, we started following this method. So we always have an interface, and then we'll use an abstract. We'll implement the abstract class using our concrete class. And then in the data provider, we have HTTP get, which is overload, which takes the variables like this, so parameter based overload. And then we have a private method which will do the actual get call using Boost ASIO. So that's the header file. I'll go to the implementation. The fundamentals controller would call the get HTTP get, and then would pass a promise. Once a promise is passed, we'll use Boost ASIO spawn, and you'll take a strand and we'll receive the promise. And in the callback, after HTTP get is completed, we'll get the response as in the callback from HTTP get. In that HTTP get, the response will send it to the promise in set value. So this way, the fundamentals controller would be waiting on the promise to be fulfilled. And once the strand finishes the callback, it will set the value in the promise. And then in the fundamentals controller where it calls the DataProvider.get, a promise is created here. And then this is a blocking call. It will wait for the future to get the value, and then in the future we get the response, and then we'll save that response to S3 using put method. So this way, when the client calls the fundamentals controller, the call is sent here. If the data is not already in S3, then we create a promise and block the thread here. So it's a blocking call. While the spawn, which is running a coroutine in a strand, will finish. Once that is finished, the promise would be set. Then in here we get the value. So we had to do this way because we wanted to make HTTP GET a coroutine so that it can run independently of any other calling thread. But since this is a REST API, at the same time we cannot do asynchronous. We need to get the data from the coroutine to pass it back to the client. So that's why we'll block the main thread here. So since it's a blocking call, there is a possibility of deadlock. So we'll discuss that at a later session. And we'll see how to avoid this blocking call, or maybe do a exponential backed timed wait on the future, so that we don't just block on the future, but we'll do a timed wait, and after a couple of tries, we'll send 500 response to the client. So we can do that at a later point. So I'll go into the HTTP client implementation again. Like I mentioned, we have a strand, and we created a strand here so that we ensure that this HTTP GET happens only at one time. Only a single thread can run it. So that way it's a synchronization mechanism. If there are 5 threads running the IO context, we will ensure that only one thread would be running this function at a time. So the strand ensures that synchronization. And in the strand, we do HTTP GET. HTTP GET implementation is already provided in the Boost ASIO documentation. I use the same. And then we already discussed this in previous sessions in your Boost WebSockets and Redis streams. In all of those sessions, we discussed this code base. So I won't go through that in details. We have a resolver. Resolver will take a host lookup, and it'll do resolve on the host name, and it'll return the IP addresses. Once we get the IP addresses, we connect asynchronously to that IP address. And then once we connect, we start the SSL handshake because this is a HTTPS endpoint. And then we create a request for GET, create the GET request. And then we send the GET request async write. We write the send request. And then once we get the response, we do async read, get the response from the client, and then the response would be in the buffer, flat buffer B. Then we take the response. So we send a response in dynamic body, and once we get the response, we take the response body, get the data, buffers to string, we convert that into buffer to string, so that the client doesn't have to rely on the Boost library. So we pass a callback, which is this callback. Our callback is in this format. It gets a single string as the parameter. We get the response. Then the response would be sent to the promise, which we captured using lambda capture by reference. And then we set the value in the promise. So we do a callback. The callback is nothing but the lambda we pass, this lambda. So once we get the response, the fundamental controller will listen to that response. It's controller. So here we get the future.get, get the response, and then we send it back to the client. So with that, I discussed the Boost ASIO spawn, future and promise, possible deadlock, which I mentioned, and in a later point, we'll see how to avoid that busy wait on the future. Maybe through an exponential back off, we can wait. Then I discuss the REST client, GET client, which is the same implementation as the samples in the Boost ASIO GitHub page. So you can look at that. Now I'll discuss the unit test and the integration test. Since this is an IO context-based test, we had to create an IO context. So I'll go to the test. So integration tests, we'll just discuss the DataProvider integration test services. DataProvider test. So you could ignore the details here. These are the provider URLs. The provider sends us some JSON file. So we create the data provider and give an IO context. We create the IO context here. we provide that IO context to the data provider in the constructor. Then we do DataProvider.get, and then we pass a lambda here. This is callback based implementation. So we pass this parameter, this lambda. So once the HTTP get is complete, this callback is called, and the response is saved to the response, which is captured through the lambda capture. And then we do check if assert false, the response should not be empty. And also for the test to run, we need to run the IO context, so we are running it here. Similarly, in a promise-based implementation, we create a promise here, then we get a feature from the promise. Then to the get call, we send the promise. So once the get call completes, this function internally creates the lambda, which we discussed. The promise is fulfilled. Then we do the IO context.run so that the get call is run and it's complete. We do IO context.run, and in the end, we check the feature.get is a blocking call. So once this is returned, we have to check if it is empty or not. So assert false. So that is how the unit tests are done for that Boost ASIO based code base. With that, I'll close today's session. If you have any questions or comments, please reach me out in the discussion tab in the documentation page or in the YouTube channel. Thank you for watching.